Welcome. In this video we're going to talk to you about right triangles, and for the first time we're going to take a look at what the Pythagorean Theorem is and how that's related to right triangles. Some review from 5th grade and 6th grade geometry. We should know there are 3 classifications for triangles. We could call triangles either acute, obtuse, or right triangles. Acute triangles are those that have all 3 angles less than 90 degrees, or all acute angles. An obtuse triangle is one that has an angle that's obtuse, greater than 90 degrees, and a right triangle has one right angle or one 90-degree angle in it. Our focus today in an 8th grade is going to be mostly on the right triangle because there's a special property related to the right triangle. Today our focus is going to be to understand that the Pythagorean Theorem, a formula we're going to talk about, allows us to find the missing side length for any right triangle we're given. If I know 2 side lengths of a right triangle, this formula, a squared plus b squared equals c squared, helps me find the missing side length for the right triangle. It's named Pythagorean Theorem after somebody, Pythagoras, who was one of, but not the first person to figure out this formula existed for every right triangle, or this pattern really did exist in the world. Important vocabulary. The hypotenuse, when we talk about a right triangle, the hypotenuse is the longest side for a right triangle. We're going to label it C in our formula, a squared plus b squared equals c squared. That's the first key. Here we see this purple right triangle. It has side lengths of 4, 3, and an unknown side length, and we've labeled them A, B, and C. We didn't pick that at random. The longest side length is going to be C, the hypotenuse always. A and B are going to stand for the 2 shorter sides. Once we know this information, the hypotenuse is the unknown and the 2 known ones, 4 and 3, are going to go in for A and B. We simply substitute or plug those numbers into our formula. I know that A has a value of 4, I know B has a value of 3, so I substitute or plug them into the equation. Next, we're going to evaluate those exponents. 4 squared gives us 16. 3 squared, 3 times 3 makes 9. The following step, add 16 and 9. We get 25 is equal to c squared. Pause the video and figure out, if we know this now, c squared equals 25, what value does c have to take in this triangle? Welcome back. Hopefully you realize that c had to be equal to 5. Some of you would have solved that by what we call inspection. You said, what number squared is 25? And you realized 5 times 5 is what would give us 25. Other students may recognize that the inverse operation of squaring c is to take the square root of it. So if we take the square root of c squared, square roots and squared cancel each other out. So that would get us down to c. And we should remember from prior grades, anything I do to one side of the equation, I need to do to the other side. So those of you who solved by inspection in your head really took a square root from both sides. That's how we solved the Pythagorean theorem for the final step, because that's how we cancel out the squared. The green triangle is another right triangle, but a little different. This time, when we label A, B, and C for the hypotenuse and the 2 legs, we realize that we know C. We already realized that C is equal to 5, so we're going to be plugging in a 5 squared for c squared. We know that A is equal to 3, so A becomes 3 squared, and this time we don't know what B is. These problems are a little different because now after I square or evaluate the 3 and the 5, 9 plus b squared equals 25. The 2 known values are not on the same side of the equation. So I need to think back to 6th grade, 7th grade, use my inverse operation of subtracting 9 from both sides, because that will get the b squared all by itself and allow me to combine the 2 constant terms on the right side of the equation now. 25 minus 9 leaves us with 16. Again, pause the video. If we know that b squared equals 16, what do we think b, or side G, has to be? Welcome back. Hopefully you realize that b has to be equal to 4 here, because 4 squared would make 16. Again, we could have taken the square root from both sides. The square root of b squared is b. The square root of 16 would have been 4. If we plug a 4 up here, we see that makes sense, a side length of 3. This is 4, a little bit shorter than the 5, but longer than the 3.